I'm Lillian Dumas. I'm a senior from Utah, and I want to talk about the math and science program at St. John's. We tend to advertise ourselves as like a reading school, which people think of as being philosophy and literature, but half of the program is actually history of math and science. And it says on your degree, you have a double major in philosophy and the history of math and science. And the way we do it is really one of the main things we're focusing on. We dwell on one author for a long time. Almost all of freshman math is Euclid, and a lot of the other authors we work with for half a semester or longer. So it really gives you an opportunity to get to know how a particular person thinks. And I think to work with these philosophical questions of how we think, how we come to make a good argument, make a justification, in a way that's really practical. It's like testing your more abstract ideas of how you come to prove or understand something. Just like the rest of the program, the math and lab classes run chronologically. So you start freshman year and you're reading ancient Greeks, you're doing ancient Greek geometry, and you go forward not so much with an interest in coming to the conclusions that everyone holds now, but in understanding the path that we've taken to get there. And so you read Ptolemy and you get to really know the geocentric model of astronomy, and then you read Copernicus and you read Kepler and you read Newton, and you get to know the modern view. And you do this in everything. In senior lab, we're reading things now that were written when I was alive. And we do everything this way. And so the focus really becomes not just on getting to know what the conclusions are, but really interrogating where they came from. One of the major kinds of thinking we're doing, in the math program especially, is getting to know how proofs work. I mean, it's the focus completely freshman year with Euclid. It's a way of thinking that we learn rather than a fact. And it really becomes a pattern that you use for everything that you do going forward. And it's identifying what's given and what's set out to prove. Euclid lays it out really clearly. He's always explicit. So for example, you have two triangles, and they have pairs of equal angles, and then one pair of equal sides. We know those triangles are going to be equal. And so if we're really clear on our givens, which are those two sets of equal angles and the one set of equal sides, we know exactly how far we can extend the conclusion of the proof. So here, let's look at some triangles. Okay, so if I have these two triangles, and I make them so that those angles are equal, and these angles are equal, and then these sides are equal, but I don't know anything else about them. I know that the other two sides here and these two angles are going to also come out correspondingly equal. In contrast, I might have a triangle where I know that I have between two triangles, I have two equal angles, an equal side, and then another equal side, and they might not be the same triangle. And we can see here, if I was going to draw a circle that has its center here and has this line as the radius, potentially that circle could have two intersections with the third side of my triangle. So if I extend this line out, it's the same length as the first one, so that's the triangle I have over here. But this line is a different length, like as we extend it out this way, and the whole angle in here is a different length. So some starting conditions are going to give us this end result, equal triangles, and others aren't. And I mean, this is what all of our proofs are going to be working with. But if we're really careful in identifying the givens here, we can see in these triangles where I had my side angle similarity given. The equality of the triangles, to prove of the proof, comes right out of that. So the given is really the cause of the thing that we conclude, the thing we were trying to prove. And the proof really is just understanding the implications of the given. Whereas in this case, if we really understand what the given is, we see that there's multiple possibilities for how that angle and two sides can be arranged. It's really important to think carefully about what the given is in Euclid. It's really good training because he's clear about it in a way that nobody else really is. The vast majority of thinking is a kind of given to prove thinking where we're talking about the essences of things. We're getting to know what comes out of a thing being the way that it is. So it's a great pattern to get familiar with. And it's really something that leads us into asking these great definition questions. Like, what really is a straight line? Maybe we have an intuition about how a straight line behaves, but to try to define that behavior might actually prove itself really difficult, especially if we're being careful to do it in a way that doesn't rely on the assumption that we already know what a straight line is. And I think this is a lot of the work we do in the math program, in the lab program, where freshman year, you're not allowed to say the word molecule for a long time. You're not allowed to say the word oxygen. You're certainly not allowed to say energy because you don't really understand what it is yet. And the project becomes defining these things and getting to a point where you really do know where they've come from, how you're encountering them, why you would begin to start thinking about them. So we're a philosophy school, but we do math and science. We really do math and science in a way that's continuous with the philosophy that we do. And actually, math and science, particularly in the modern world, are inherently continuous with philosophy. You can't read quantum mechanics without talking about Kant. And you can't use Gödel numbers without talking about how deeply language is enmeshed in the way that we calculate and what the reality of numbers or of geometrical concepts or even of physical phenomena really is. It's really all woven together. I think some people feel some trepidation about the math and science program, and that's understandable. It is hard. There's a lot of hard work and a lot of things that we do that other schools don't do. But I think in that, you really see the way that it opens up for everybody. So most colleges, if you're gonna spend as much time as we do on math, you're listening to a lot of lectures and you're taking a lot of tests and you're learning, you're memorizing facts and you're learning the systems that other people have already found. And here, there's a lot of guidance from the thinkers that we're reading. We are learning from them, but we're also learning how to make our own way through their thought. We have, just like our seminar and language classes, the math and lab classes happen just sitting around a table and it's discussion based. In math, you go up to the board and you do demonstrations, but it's all about having a discussion. You really almost can't get left behind if you care. And so much of the experience of doing math and science here is learning to care about things you maybe didn't think you would care about. I've been a math assistant here since my sophomore year, and I've walked people through freshman, sophomore, and junior math. And so often, I've seen people just come alive working with Galileo's wheel paradox, where he shows that seemingly circles of different sizes have gaps and either different amounts of points or points of different sizes in them. And people discover questions and this kind of underlying reality that not only shapes the world around us, but shapes our own minds that we're not always sensitive to. We write math papers instead of taking exams. And I think that too is really, it's a thing that pushes you to think about essences and definitions and to think carefully about how arguments are being made. A lot of good math papers are really technical in a way that's guided by a concept. So good freshman year math papers often look like taking a definition, maybe from Euclid's Book 5, a definition of what it is to be in a proportion, and going through propositions and really seeing how that definition gets used. What exactly does it mean? You're not expected to just hear everything and go into working with it as a finished concept. I think you're always coming back to this thing we said at the beginning. What is it now? How do I understand it better? Having done the technical work. And for that reason, I think it's really accessible. I think if you're afraid of math and science, you shouldn't be in the St. John's context. It's for you. It's for everyone who lives in the world. And if you're excited about math and science and you want to take it seriously, maybe you're thinking of going to grad school for it, I really don't think there could be a better foundation. Again and again, I hear people saying, oh, I wish I could just take the whole program from scratch. No, just take it from the beginning now that I've come to the end. And I think so much of that is because everything we're doing is so difficult and it's so rich, and there's always more to do with it. And if you want to, if you are able, you can put in a lot of time and a lot of work and draw out so much that's fascinating. And I think if you're not feeling excited about that already coming in, you're gonna find areas where it's all you wanna do. So I'm graduating this year, and I'm thinking a lot about how St. John's has changed me and what it's prepared me for. What I'm concretely planning on doing is spending the first year or so after I graduate working on developing ecological skills, traditional skills, working at a bakery, working at a local organic farm. And a lot of this doesn't look all that continuous with the St. John's education. But I think in reality, it's a great example of what St. John's has done for me. I feel very confident to start encountering the natural world and the question of how we live well and how we sort of put ourselves into community well, and be really sensitive to what I encounter and what I observe and make experiments. And I'm really thinking of my plan for the next bit of my life as continuing to get to know reality, to know what the things around me are. And I mean, I want to learn how people have always been keeping themselves alive, because I think deep in that question, there's the ability to start to address what it is to be human in the world as such. And there's this great openness that I think the St. John's education has given me, where I have so much thought at my disposal. And it helps me go into the modern world and see things that we all tend to talk about and assume all the time as not necessarily the only way that there is to think. I take less for granted, and it's really prepared me to start doing this practical hands-on work that looks separate from the philosophical work in a deeply philosophical way.